Hello grade 11s. Today you're looking at day 2 in the matrix unit, which is matrix multiplication. You'll remember we explored using a matrix to represent or to organise information. We looked at adding two matrices together, which was very straightforward, and we also looked at multiplying by a scalar, which was also very straightforward. Today we're going to look at what happens when we try and multiply two matrices together. First of all, we're going to consider not worrying about matrices, just a situation that we'd need to use multiplication for. So I suggest you pause the video and take a read of this first paragraph and think about the two calculations that would need to be done. Okay, so hopefully you've had a think about those. Obviously we have shop A, where Bert wants 2 plates, and in shop A they cost £2, so we'd have to do 2 times 2, 3 cups at £3 each, and 4 bowls at £4 each. And, I'm not sure, what does that make? 4 plus 9 plus 16. Okay, hopefully that makes £29. Okay, and then we do a similar set of calculations for shop B. So we do 2 by 3 plates. Hopefully you are skipping some of this and just going straight to check the answers. Okay, we're going to have 6 plus 6 plus, 18, which is 12 and 18. That is £30. Okay, so those would be the sets of calculations we would do in order to find out how much it costs from shop A, how much it costs from shop B. But of course, based on the title of this lesson, we're going to look at an alternative way of doing this calculation, and we're going to use this situation to illustrate how matrix multiplication works. Okay, so what we're going to do is we're going to represent Bert's needs by a 1 by 3 matrix. So that's going to go plates, cups, bowls. That's the order we have in the question. And Bert needs 2 plates, 3 cups, 4 bowls. And we're then going to represent the costs of plates, cups and bowls in our two shops in a 3 by 2 matrix. So we're going to have shop A, the plates cost 2, the cups cost 3, and the bowls cost 4. And then in shop B we had 3, 2 and £4.50. Okay, so what we can do is we can do the same calculations basically. So when we multiply two matrices together, this is what happens. We take the rows from the first matrix and we multiply it with the elements of the column in the second matrix. And so the number of elements in a row of the first matrix needs to match up with the number of elements in a column of the second matrix. Otherwise, it'll be mismatched, won't it? So we'll take the first element in the row of the first matrix, which is 2, and we'll multiply it with the first element in the column of the second matrix. So we'll do 2 times 2. Then we'll move on to the middle elements, 3 times 3, and we're going to add them together. And then we'll move on to the third elements. And of course, if there were 4 elements, you'd keep going. Okay, so that is our first part of multiplication. So I've done the first row and the first column. Okay, we're going to move on and we're going to do the first row again with the second column. So the answer, the result of the first row and the first column went in the first row, first column position of our answer matrix. This is the first row, second column. So it's going to go in the first row of our answer. The second column is going to go in here. Okay, so we'll do the same thing. First elements are 2 by 3, plus the middle elements 3 by 2, and then the final elements 4 by 4.5. Okay, and of course we can simplify each of those. So 2 times 2 plus 3 times 2 plus 4 times 4 is 29. And then the other one comes to 30. Okay, and then that would give us the total cost. So that is shop A, That's shop B. If we had two different people's needs, we could set this up a little differently. So we're going to introduce Bert's friend George. George also wants plates, cups and bowls, but in different quantities. So this time we'll do plates, cups and bowls. And we'll have, let's stick with Bert at the top, 2, 3 and 4. And then George underneath will have 2, 1 and 4. And then the prices aren't changing. So we've still got shop A, shop B. I'm just copying these values from above, 3, 2 and 4.5. Right, so we are multiplying a 2 by 3 matrix. I'm just going to write down what it is, by a 3 by 2 matrix. The important part is that these numbers match. The number of elements in the rows of the first, so how many columns there are, match with the number of rows in the second. So that we can multiply an element from the rows of the first with an element from the column of the second. Okay, we'll start with first row, first column. Now that I've highlighted this, maybe you can see we're going to have to do 4 sets of calculations this time. We're going to do first row, first column. We're going to do first row, second column. Then we're going to go down and we'll do second row, first column and second row, second column. So we will end up with a 2 by 2 matrix. I don't know if that's big enough. Let's make it a little bit longer. We're going to end up with a 2 by 2 matrix. Okay, so we already know 2 by 2 plus 3 by 3 plus 4 by 4 is Bert shopping at shop A. Okay, I'm going to move on to first row, second column. It's going to go in the first row and the second column of our answer matrix. So 2 by 3 plus 3 by 2 plus 4 by 4.5. Okay, I've done the first row with all my options in the second matrix. I've got to move on. I'm going to move on to the second row and I'm going to do it with the first column. So of course the answer will go in second row, first column position. 2 by 2 plus 1 by 3 plus 4 by 4. And then finally, you know what's coming next. We're going to do second row, second column. And of course it goes in that empty second row, second column spot in our answer matrix. And this is, who's his friend? George, buying at shop B. Okay, and just as before, I'm going through first element, second elements, third elements, multiplying the elements together and adding the results. And of course, we can simplify that. Okay, I think I should know the first two are 29 and 30 from before. All right, we've got 4 and 3 and 16. That makes 23, I hope. Please correct me if I'm wrong with these. Then 6 plus 2 plus 18. I think it's 26. Okay, so of course, we've done the multiplying. It's important that you're able to understand what each of the values represents. So knowing that this one that I've just drawn a box around means it will cost George £23 if he shops at shop A for his 2 plates, 1 cup, 4 bowls. Okay, so hopefully that gives you an idea of how to multiply matrices. You're going to look at some example questions on the next page. I will fill in answers on OneNote. I won't bother going through how to do all of those. Let's just read the note at the top. In general, 2 matrices of size A by B and C by D can only be multiplied if B is equal to C. The resulting matrix is of size A by D. Okay, so if we look at the last example, this is the B position, and this is C, they match, and the answer is an A by D matrix, a 2 by 2 matrix. That's what we ended up with. That was our answer matrix there. All right, I suggest you stop and you have a go at answering these, then check on OneNote for your answers. Okay, so I'm guessing you have finished that now. Hopefully you realise that questions 1 and 2 are the same matrices, we just switch the order. We know when we're multiplying numbers that the order does not matter. 3 by 5 is the same as 5 by 3. That is not the case all the time with matrices. In fact, most of the time it's not the case. So it's just something to be aware of. The order does matter. We can also do these calculations with our calculator. So I'll go through doing that now, maybe with question 4. Okay, so I'm going to go and I'm going to press the fraction box. And in the fraction box on the right hand side, you'll see some kind of arrays. You can see that there's a square array, then underneath it there's a column, and then to the left of it there's a row. So I want the row option, so I'm going to put in the matrix 4, 5, 0. So I'm going to go for 4. You can either click on the space or you can press the, I don't know if that's a comma or an apostrophe, but the key next to the enter, and you'll get a 5, and then you can keep on going and it will keep stretching the matrix. So that's 4, 5, 0. I want to multiply it with a 3 by 3 matrix. I'm going to go back to my fraction box. I'm going to go for that square one in the top right. And I want to put in 2, 3, 1, 2, 3, 1. Okay, to get to the next row, I need to click. Don't press the apostrophe, otherwise you will keep extending the matrix, which you don't want to do. Negative 2, 1, 3. Negative 2, 1, 3. And then I'm going to click on, you see I've clicked on that plus minus. I'm going to go for 1, 2, negative 1. Right, just thinking about this, the number of elements in the row match the number of elements in the column of the second. I've got a 1 by 3 matrix and a 3 by 3 matrix. So I should get a 1 by 3 as my output, which is what I get. And hopefully that matches your answer that you did by hand. So matrix multiplication on the calculator is quicker. You do need to be able to do both ways for our course. There will be plenty of times where the types of values you have, your calculator can't cope with. So please don't see this as a case where, well, it's a calculator heavy course, I don't need to worry about doing this manually. You will need to do that. But if you've got the option, it seems like the calculator is quicker. Okay, the final thing that we're going to look at is the identity matrix. And it's this, we can have it in any size we like, any square size we like. This is a 2 by 2 matrix. And you can see the ones fall on the leading diagonal and there are zeros elsewhere. If we had a 3 by 3 identity matrix, often we write that as I and a little 3. It would be a 3 by 3 matrix with ones on the leading diagonal and zeros everywhere else. And so on for the different sizes. Okay, hopefully you've had a go at these multiplications. If not, let's do it quickly now. So 4 by 1 plus 7 by 0. And then I'm going to do 4 by 0 plus 7 by 1. And then I'll keep going, negative 2 by 1 plus 3 times 0. Oh, I just realised I wrote 70 above. Let's change that for 7 times 0. And then negative 2 times 0 plus 3 times 1. And what we should find is that we end up with, when we simplify it all down, we end up with this, which is what we started with. Have a go at the second question where we're switching them around. We're doing the identity matrix times this other matrix. You'll see you end up with the same result. So basically what we're seeing is this identity matrix takes the same place in matrix multiplication as 1 does in normal multiplication. That is, it doesn't affect it. It's called the identity matrix, and we've talked about the notation. So in this case, the order doesn't matter because you're effectively multiplying by 1. At the moment, that probably won't seem terribly useful, but it will be a property that we will find very useful as we continue on. All right, folks, I hope that you haven't had to rewind too much to go back over things. Do have a go at the homework. Hopefully you can get it all done in class today. And I hope to see you back at school tomorrow. Bye-bye.